different types. One of them is reflective symmetry. Reflective symmetry, and the other one is called rotational symmetry. Oops. Rotational symmetry. Okay. Now, reflective one is just like it says, and the question you need to ask yourself, for example, I'm going to draw something. Where's my shapes? Well, let's just draw a square. Make yours as square-like as you possibly can. Okay. When you hear the word reflective symmetry or just general symmetry, usually this is the one they refer to, and that is simply this. Can you draw a line that when you fold it, when you fold the shape on that line, the two halves match up? Halves, the two halves match up. And it's called reflective because it's like looking in a mirror. When you look in a mirror, that is the kind of symmetry because the mirror is kind of that axis where it's an exact duplicate of something. So here's the example here. With our square here, if I were to draw a line right down the middle here of this square, and I folded that square on that line, these sides will match up, everything will match up completely and nicely. I could do it with a piece of paper. If in fact I had a piece of paper. Well, I don't know, waste this one. So for example, this is a rectangle, but if I fold it, here's my line of symmetry here, because when I fold this, everything matches up. Okay, I don't have any one side sticking out over the other. It doesn't look like this. Okay, it doesn't look like this because they not match up. They match up exactly. Okay, so I could fold it like that. I could also fold it like this. Okay, that's going to match up over top of it. Any other ways I could fold it? Calvin, I could fold it. Yep, I could fold it on the diagonal like this. And I could fold it on the diagonal like this. A square has 1, 2, 3, 4 lines of symmetry. Okay, it has 4 lines of symmetry. I wish I had a little more room here. Maybe I can shrink this up a little bit. So I can get my square to look the right way. That really doesn't work, does it, with the square? It kind of messes up my square. What if I did one side and then did the other? Whatever. Square kind of got messed up there. Now you have to be careful, because if I asked you how many lines of symmetry does a rectangle have, how many lines of symmetry would a rectangle have? As we have to be a little careful there. Gary?
2.
Just 2. Where, Gary?
Across.
Across.
And straight down.
Straight down. Are there any other ones? Jacob?
Diagonal.
Now, here's where I said you have to be careful, because if you do a diagonal, and that's why this piece of paper works, because it is a rectangle. If you do the diagonal, here is what happens. Even though you might think it is, you do get 2 halves that are equal, but they don't reflect on each other, because this is what it looks like. Here's my diagonal, and they need to match up. And if they don't match up, that's not a line of symmetry, so it's not a diagonal. This only has those 2 lines of symmetry. Nicholas?
Well, I was going to say, if you were going to count like a square as a rectangle, it would have 4.
Right, but we're going specific names here. Correct. How about a circle? If you have a circle here, how many lines of symmetry does a circle have? Well, we could do one right here. We could do one right here. And we could do one right here. We could do one right here. I suppose we could make one like this. Make one like this. A circle has an infinite amount. You could not draw all the lines of symmetry because every diameter that you could draw would be a line of symmetry. Because no matter where you fold a circle on one of these lines, it's always going to match up with each other. How about a? Let's look at one more here. How about this triangle? How many lines of symmetry would that triangle there have? Eli? Just one, right down the middle. Okay, if you folded it like this, those two halves will not match up. But another triangle like this one, if it happened to be an equilateral triangle, oops, I guess I can't fix it now. An equilateral triangle, one that has all equal sides, would have 1, 2, 3 lines of symmetry, because all those halves would match up there. Okay? Now, with that, we haven't talked anything about rotational symmetry. So again, I'm just going to go to a new page. Rotational symmetry. Write down the definition of this, because it's a little more wordy, a little more complicated here. If it has rotational symmetry, if when you rotate it, comma, it has the same shape more than once in a full turn. And you kind of got to have the examples really to understand it, so I'll let you write that down and then we'll talk about it. Okay. Say you've got this triangle here. Okay. Here's the deal. First of all, every shape will look just like itself if you spin it 360 degrees a whole full turn. That's why it says it has to be more than once, because if I take this triangle and I spin it one whole time, it's going to look just like when it started. Okay, maybe I should slide it over here. What rotational symmetry is when you spin it a half a turn or any amount of turn, will it ever look just like this before you do it one full turn? Okay, and in this case, this one does not. It does not have rotational symmetry because it doesn't ever match up until you do that whole turn. Now, if I were to make it, let's make it an equilateral one. Get rid of this one. Copy this one. Cut. Oops. I'll figure this thing out here. Now this one here, okay, if I take this shape, and if I spin it only this much right here, and I've only gone a third of a turn, looks just like it, then it does have rotational symmetry. Okay, and I spin it again, looks just like it here. It actually appears 2 other times besides that last time. So the answer to this is just yes, it has rotational symmetry. Because it looks just like itself before you spin it a whole turn. Here's a couple of things they have. The book asks you this question. The letter M. Now if I can draw it real. The letter M, let's do an M like this. Rotational symmetry or not? Will it ever look like a letter M before I go all the way around once? No. What about regular symmetry? Is there a line where you could draw it where you fold it upon itself and it look just like a mirror image of it, Peter?
Down the middle.
Right down the middle here. If you did it right here, cut it and fold it, that would be it. So it has no rotational symmetry, but it does have reflective symmetry. What about the letter A? Love the way. Take away some of the squiggles I put on it there. Does it have rotational symmetry? Yes or no? No, because again, you know, I turn it a quarter of a turn, it's going to be laying on its back. I turn it upside down, it's going to be just like that. I turn it 3/4 of a turn, no. Does it have reflective symmetry? Yes, it does. Right down the middle again, even though I got some squish little extra things. What about the letter H? Rotational symmetry, Alexa?
Yes.
Why? Because,
If you turn it, it'll just look like an H back on the
exactly. If I had drawn this without picking my pen up, let's see if I can do this. Here's my H. What Alexa is saying is this. Copy. If I take this H and just turn it a half a turn, it looks just like itself at a half a turn. So yes, it has rotational. How many lines of reflective symmetry does that H have? Christine?
2.
2. One right here and one right here. So that is absolutely, positively true. Is that all we talked about? I thought there was something else we talked about. I think that's it. Oh, no, they do talk about transformations.
Here.
Yeah, I know. Take a look though at page